गार्ड साहब को बोल दिए हैं सर।
हाँ
तो बोले कि ठीक है चाबी आप हमको दे दीजिए लैब का, हम अंदर में रख देंगे जहाँ आप रखते हैं वहाँ।
ठीक ठीक
कनेक्शन हो गया ना?
हाँ हो
हाँ
गया
हो गया। हम निकल रहे हैं।
हाँ प्लीज
गुड नाइट सर।
गुड नाइट थैंक यू वेरी मच
Welcome, Vinod sir. We can
Yeah.
wait for up to 6 o'clock.
Okay ma'am I'm waiting for that how are you ma'am
Fine.
okay fine
Are you in the office or reached home?
no just office they have closed down that but just I have requested him to just keep open the meeting hall so I'm sitting here in the meeting hall of my office
Okay, I think you are staying in campus like that.
no ma'am office
Okay.
okay.
How was the election? Everything was there?
Election, I didn't go to Bihar, ma'am. Actually, I'm working at Jharkhand, ma'am.
Yeah, sir.
So this, due to having this schedule, I didn't go there, ma'am.
You didn't vote. Your vote.
No problem, ma'am. It's okay.
Here also elections declared, sir.
Okay, so which month you have, ma'am? Next month?
December.
December, yeah. Okay.
That panchayat election.
Yeah, here we
Local
have.
assembly.
Yeah, here we have this legislative election, ma'am. MLA.
Yeah. Okay, sir.
Okay, ma'am. Okay.
I will give a small introduction.
Yeah,
After
no
that, you
problem.
can start.
Please, ma'am, please.
Okay. That I think I will start by 6 o'clock only.
Okay, ma'am, no problem. Sir.
Meet my coordinator, that is Professor Danya Raj
Okay, so
and
he's
Sujit Kumar.
just side of you.
Hello, sir. Hello, sir.
Yeah, hello, ma'am. How are you, ma'am?
Oh, fine, sir.
Fine, ma'am.
Sir, your institution in Jharkhand, right?
Yeah, I am staying at Hazaribagh, Jharkhand, ma'am. But actually, I am from Bihar, Patna, ma'am.
Okay.
I returned back from the abroad, ma'am, Muscat. That place I was working as associate professor. So
Yes, sir.
after returning back, I joined this university.
Okay, sir. Shubli ma'am, we will start at 6 o'clock, right?
Yeah, no
Yeah.
problem. Even if you'll say that, I can wait 5-6 minutes more like that.
Okay.
5-6 minutes?
No, at what time you are telling me to start this?
Okay.
Sir, time is 6 o'clock itself.
Yeah, so 6 o'clock I have to start.
6 to 7:30, sir.
Yeah, 6 to 7:30.
Yeah.
So I'll be start 6 o'clock sharply, or I have to wait for 5-10 minutes more for them.
I will give the introduction, sir. After that, you start.
Please, ma'am, please. Okay.
when participants reach 50, we can start.
Yeah, no
50.
problem. Please.
Shall we start, respected participants? Shall we start now? Okay, with all the permission of the participants, I would like to start the session today. Myself, coordinator, Dr. Shibili Joseph, and today we are in the second day of our session. I hope all are back from the hectic workload. And today we have Dr. Binod Kumar from AISCCT, Jharkhand, Hazaribagh, Jharkhand. I will give you a short welcome, sir, to this function, and welcome participants again to day 2 sessions. I will give a short description about our resource person. He is an eminent professor from AICT, AISCCT University, Hazaribagh. Dr. Binod Kumar is an accomplished academician, researcher, and administrator with over 27 years of rich experience in teaching, research, academic leadership, and institutional development. He is currently serving as the Director of Vocational Education at AISCCT University, Hazaribagh, Jharkhand, where he plays a pivotal role in designing academic programs, developing skill-oriented curricula, fostering industry partnership, and promoting quality-driven vocational education. He worked closely with IQAC to strengthen academic standards and enhance teaching learning process across departments. He holds PhD degree in computer science from Barakatullah University in 2009. His academic roots are strongly grounded with postgraduate and graduate degrees in information technology and computer applications. Over the years, he has taught a wide range of subjects, the PG and doctoral levels in high performance computing, supercomputing, data structures, software engineering, compiler theory, artificial intelligence, etc. His teaching style emphasized conceptual clarity, practical application, and research-based learning. Dr. Kumar's research interests span computer security, e-commerce security, data security, payment to transition security, and speech processing. His doctoral research focused on analyzing security models to enhance effectiveness and alignment in digital systems. He has supervised numerous PhD scholars, many of whom have completed their degrees under his guidance in areas related to cloud computing, cybersecurity, epidemic modeling, and machine learning applications. The global academic presence, Dr. Kumar has served as an assistant professor at Higher College of Technology, Muscat, Oman, and at Mekelle University, Ethiopia, where he contributed to curriculum innovation, academic coordination, and faculty development. His international exposure has enriched his pedagogical perspective and strengthened his expertise in outcome-based education, quality assurance, and academic governance. Throughout his career, he has authored several research papers published in reputed journals and international journals, indexed under ABCD categories. His work addresses key challenges in intrusion detection, wireless sensor network, augmented reality, and machine learning for healthcare. He has also presented numerous papers at conferences across India, the Middle East, and Africa. In addition to research publications, he has authored academic handbook on Linux with MySQL, MS Excel, and formal language theory, which serve as a valuable learning resource for students. Dr. Kumar has actively participated in several FDPs, workshops, and international conferences on AI, cybersecurity, high performance computing, and emerging technologies. His recent include 31st IEEE HIPC conference and AICT CDAC Master Training Program on HPC. His administrative experience includes serving as a Dean Academics, Head of Department, Course Coordinator, and Head of Section, where he ensured academic quality, faculty mentoring, curriculum development, and student progress. Known for his strong work ethics, leadership skills, and dedication to academic excellence, Professor Dr. Vinod Kumar continues to contribute significantly to higher education, research, innovation, and capacity building in the field of computer science and information technology. Thank you. Welcome, Vinod sir, for the program. Thank you. Thank you once again. Welcome.
Thank you, ma'am. Thanks a lot. First of all, I will say good afternoon or good evening to all the participants. And thanks for the organizer for inviting me to have a talk with you people. So I have been offered to discuss about the cryptography and the digital signature. So today we'll discuss over those. Just a little bit, let me arrange all the things. Simply, ma'am.
Yes, sir.
Yeah, have you given the complete right to this run this PPT like that or sharing the
Yeah.
screen?
Yeah. Can you show from there? Any problem?
Yeah, this I'm trying to scroll, but it's not scrolling, ma'am.
I think
Sir,
you.
please
Then
keep it as slideshow, sir.
Yes, slide. So I did, ma'am.
you close and once more open, sir.
So like close and again. Okay.
That will be convenient for you rather than showing by me.
No.
That I am.
This screen is visible to you people?
Yeah, this was visible earlier. Now you give once more present again.
Yeah, so this screen you are getting that I'm scrolling this one. I don't think so, yeah.
Sir, now your screen is not visible, sir.
No.
Sir, you should present it, sir.
You are made as co-host, contributor, sir.
Yeah, screen sharing.
Yeah.
Now it is visible, sir.
Yeah, but it's not running, ma'am, I think.
Your PDF, sir.
Simply, ma'am,
Yes, sir.
can you run this file from your side?
Yeah, you. I will present now.
Yeah,
I
ma'am.
will try.
Okay, please, ma'am.
I am also opening the PDF.
Please, ma'am.
Are you getting?
Yes, it's visible.
All the people getting that?
Yes, yes.
Okay, ma'am. So today we will discuss about the cryptography and the digital signatures. Just the next page I want to get, ma'am. Yeah. So today the topic for discussion, cryptography. We'll discuss the common working procedure of the cryptography. And after that, we will discuss the what is the classical method. I mean, what the methods currently we are using for the cryptography. After that, we will also discuss the quantum computing, or that's a mechanism or techniques that we are using in the cryptography. And after completing this one, we'll come to the digital signature. First, we will have the basic overview of the digital signature. After that, we'll have the classical methods of technique using that we are using for the digital signature, and then we'll come to the quantum methods of using the digital signature, or quantum techniques or technology that we are using in the digital signature. After that, we'll discuss what are the latest trends in area of the cryptography and the digital signature. And finally, we'll discuss the what are the research scope or research area will have the cryptography and the digital signature. So next part, please. Yeah, cryptography. I'm not discussing its the history from where we have started coding and decoding the various of the things. Actually, if you go in the background like that, a spying has started from the beginning of the civilization, and generally that they want to pass out or transmit some sort of information by hiding some other people, just make it accessible to the person whom they are sending like that. But now latest trends and many of the evaluations has been come in this area. So currently, how this those things is going to be implemented when we are sending the information one place to another place by making it secure, as well as by making it as pure as it was the source, as well as we also can put the impression like that what the information you are getting that has sent by the sender to you like that. So today methods we have the multiple mechanisms, but in basic or in simple way we can say that it is the process of coding and decoding of the informations to transmit from one place to another place securely. The person they want to send the information to the other place, so what and how they are making it inaccessible as well as unreadable for the others. So one technique they are using like that, they are scrambling the message by using the some sort of the algorithms, as by making the some sort of the transposition as well as the shifting of the character. So sender converts the readable data, that is called the plain text, into an unreadable format, that is called ciphertext. And the mechanism that we are using to convert a readable or plain text into a ciphertext, that is called the encryption. While at the receiving side, what they are using after receiving the ciphertext, they were decrypting it, and again they are getting the original message. So the process of converting a plain text into the ciphertext is called encryption, and the converting back and the ciphertext into the plain text is called the decryption. And this is the ciphertext that has been a scrambled version of the plain text. If anyone getting in between the transmission of this scrambled word, they are unable to understand, they are unable to read this. So this way we are hiding our information that a sender or that we are sending to the another place like that. Next please. Apart from encrypting and decrypting, we are also using some of the mathematical functions that we say hashing algorithm at the time of encrypting and decrypting. In the basic version of encryption and decryption, we are simply using the techniques of the transposition as well as the shifting. I mean, we are taking the sum of the alphabets, we are shifting with the sum of other alphabets. Later evaluation happen in this area. Some mathematical function has been introduced in here, so that what were they using, rather than shifting the word of the particular order with the another particular order, they were using some of the mathematical function. And what the mathematical function returning as the quotient or as the remainder, so that we're indicating that which character will replace the which one. So the in any places, if we are telling that the original message, so it is the plain text, or encrypted message, that is the cipher text. And the algorithm, I mean the technique that we are using to encrypt and decrypt the message while transmitting from the one place to another place. Next, please. Yeah. So what is the goal? Why do we want to encrypt and decrypt our messages while we transmit from one places to another places? So generally, whenever we want to do some sort of transaction online, of course, this is related with the fund or the budget like that. So if you are losing that sum, that is not good for us, or financially it's a very harmful for us. So any information related to transaction of the fund, we are hiding that. This is the reason like that bank is saying sending some sort of the OTP. Later we'll discuss that what are the different kind of the key we have, like the secret key, like we have private key, like we have the public key. Then we'll come to know what the OTP we are using, that is the one form of the secret key between the customer as well as the bank, that they want to use just to protect the transaction, so that other people cannot get or cannot intercept or cannot get deposited in their own account like that. Second thing like that, tampering. It's also possible that if information is while in transit, so some of that they can trap that message and they can alter that message and they can resend that. So in this case, what will happen? The receiver, they will get the information that will note the correct form of that, and the decision that he will take upon that, that will be not accurate and perfect like that way. So other area where we are using the encryption and decryption, like also the computer password that we use to authenticate the user. Then we have the digital certificates. Digital certificates later we will discuss when we will discuss about the digital signatures. Then we have the secure web browsing, where we put a lot of information. Some of the information is our personal related to our privacy. Then the electronic signature, we want to authorize and authenticate the person. So we are using the different kind of the scanning techniques, like thumb, like face, like we have eye, like have a cornea. So we'll discuss them. Then we authentication, simply the ID and password that we are using. But latest day, apart from the ID and password, they are using some other techniques just to authenticate the people. Then the cryptocurrencies, again some sort of the related matter to the fund like that we want to protect. And then the in internet encryption, if some message or some dialogues or some communication happen one point to another point, or one PC to another PC, or one person to another person, that we want to make it secure, reliable, with full of the integrity, then we are using these things. Next, please. Nine. Okay. So here we have the cryptography commons. I mean these techniques implemented in the classical method also, or in the computer method also. So this is the reason I have written in the common. You can find these techniques in classical methods of encryption decryption, as well as in the quantum method of encryption and decryption. So we have the three kind of the techniques. One, we have the symmetric, another we have the asymmetric, and third we have the hash function. If we say the symmetric method of the encryption, so here we have the single key that is used both by the sender as well as the receiver. Sender use the same key to encrypt the message before sending to the receiver. Receiver, after receiving the message, they use the same key to decrypt that message. In the case of asymmetric, we have the pair of keys. One is called the private key, another is called the public key. A public key is shared to the people whom we are sending the information, or people they are willing to receive the information. And private key, that is used by the sender, they send the information to the recipient. So before sending the information, they decrypt that information by using the private key and then send to the receiver. Receiver, after receiving that, they use the public key to decrypt the message, and then they get the pure or original form of the message, and then they are using that. In the case of hash, here we are using some advanced mathematical functions that we apply over the hash that decrypt the original message. And here they are not using any sort of the key, but they are always generating a message of the fixed size, or you can say that chunk of the fixed size. Second thing like that, even same message, if you decrypt the multiple time, you will get the unique version of that. They will not the clone version of that or copy version of that. Every time, if you apply the same hash on the same data, you will get the different version of encrypted form of that data. So we have three kinds of the cryptography. One is the symmetric, another we have asymmetric, and third we have hash. And this is applied in both the classical methods of computing as well as the quantum method of the computing. Next, please. Now we have discussed that the symmetric key uses a single key, and this single key is called the shared secret key, and both the sender and receiver using this key while encrypting and decrypting the message. Asymmetric key, here is a pair of key. One is the public key and one is the private key. Private key in general, if you are not using any of the certifying authority, in case of the digital signature or digital certificate, we have in between a certifying authority. Here the mechanism little bit changing. But if we are not using any certifying authority, but in that case, the public key used by the receiver to decrypt the messages, and the private key that is used by the sender to encrypt the message. Hash function, this is the one-way algorithm, and that always generate a unique form of the message. Even same message, if you will hash the multiple time, you will get the different version of that, and they will not have any match with one another like that. So next, please. So now we are telling some of the characteristics of the symmetric key. Symmetric encryption method, it's also known the secret key cryptography, and that uses a single key for both the encryption and the decryption. And due to having the single key, its speed is little bit faster. I mean, we can encrypt a large volume of the data quickly, or that will take the less time. But one problem is involved with this. Since we are using the single key to encrypt and decrypt that, so it has a little bit of prone of the less security. I mean, in between, if somebody has trapped the key, so they can take the receiver's message, they can change that, and again they can encrypt that, and they can send to somebody else like that. So here we have a bit of prone of the less security like that. Next, please. This is the diagram we have given that, how it's working like that. Plain text we have, then we are encrypting like that by using the same key. After that, we have the encrypted version of that is called the ciphertext. The other side, I mean the receiver, they are using the same key and they are decrypting that. Then they are getting the original form of the message like XYZ. Next, please. Now we have the asymmetric key. So little bit characteristics we are going to discuss that. It is also known as the public key cryptography. Here we have the different key, I mean the pair of key for the process of encryption and decryption. Private key generally, if we do not have the certifying authority. So private key we use to encrypt the message, and the public key we use to decrypt the message. But once we have the certifying authority, the mechanism will change. The public key the sender will use to encrypt that, and then the other kind of the private key the receiver will use to decrypt that. So here this set of key that is provided by the certifying authority if we have in between of that. That's the reason, see here asymmetric, here we are getting the public key. Here public key means we having a certifying authority in between of that, and this public key has been given by them to the sender, as this private key has been given by them to the receiver. But if we do not have the certifying authority in between, then mechanism get reversed like that. The sender use the private key to encrypt the message, then they send to the receiver after receiving the message, they use the public key to decrypt that. But once we have the certifying authority in between us, then mechanism will go like that. Next, please. Now hash functions. So hash function, it doesn't use any of the key. Only what it does, it decode the message. But while decoding, the one of the symptom it is showing that its output is always of fixed length of the character or fixed length of the size like that. If the length is going to be altered, means somebody had trapped this message and somebody have used this message. Then how the communication is going to be achieved? So what's happening? The sender, before sending the message, they apply the hash function over that. Hash function, they give the hash version of the message, that we say the encrypted message. After that, the sender send the original message as well as the hash one. The receiver at the other side, they also apply the hash on the message, and after that they find that if the received hash or the new hash they have generated, if they are same, they found that message has been not trapped, message has been not changed like that. Please next one. So this is the working of that. Now we are coming that the classical method of the encryption and decryption. So classical method, once we say, so I mean we are using the current generation of the computer and current generation of the techniques of storing and sending and encoding and decoding like that way. So here we follow the two techniques, either the transposition or the substitution. Substitution, simply we are replacing the one of the character with the another character, and transposition we are finding some sort of the mathematical algorithm, and that quotient or remainder will determine which character will be replaced with which character like that. And today, I mean this classical methods of transmission, we are using this kind of the techniques. We say Caesar ciphers, we have Vignet cipher, we have Playfair cipher, we have transposition cipher. But many of these ciphering mechanism now has been stopped like that. Some of them are working because we are using some of the modern technology that is advanced, and mostly we are using the hash function to encrypt and decrypt our messages like that. And next, please. Now coming to the quantum cryptography. Little bit just we are discussing about the quantum computing, how they are working like that way. In classical computing, we are working on the bits that can be 1 or 0, or that can be on or off. But here, quantum computing, if you have studied the split uh, methodology of physics like that way, what is the split methodology? So quantum physics, any one of the bit, if you leave, if you are not putting any observation on that. Then it is in form of between 0 to 1. I mean, we can say like that one bit one time can be 0%, 25% polarity of the 0, 75% polarity of 1. Then the next instant of time, it can be 50% polarity of 0 and 50% polarity of 1. Next time or next instant of time, it can be 60% polarity of 0 and the 40% polarity of 1. So that we say like that, their phases, in which phases or in which shift they are, like that way. So quantum computing, they are working on the shift of the bit or phases of the bit, like that way. Or we using some sort of methodology or techniques to disturb the bit so that we can get the desired number of bits at the desired shift position or desired phase position, like that. So quantum computing, if we are want to use to encrypt and decrypt the message, we are using two things. First of all, we are not using the guided media, because guided media we cannot send the photon. Photon is like the electromagnetic wave, like that way. So here we use the optical fiber, not like this copper cable and other twisted cable, that we are not using. We are using the optical fiber where we are using the photons. Another property of this quantum computing we have, the bits are in tangent position. Position means if we have the set of 5 bits and their phases are different. Some is 10% polarity 0, 90% polarity 1. Some is the 40% polarity 0, 60% polarity 1. So they are in tangent, I mean they are connected with one another. If you will disturb any one of the bit, suppose they have the 10% polarity 0, 90% polarity 1. If you change that like the 30% polarity 0 and 70% polarity 1, the other bits, they will also get changed. I mean their shift position will get changed, like that. So if anyone, while the transit these photons in the transition phase, or anyone trap and try to change that, so just by changing any one of the bits, all the bits shift position or phase position automatically get changed, like that way. So here it's a very difficult, first of all, to track that one, and secondly, if anyone trap and attack over that, the both the sender and receiver will come to know this information has been tracked and read by someone else, like that. Classical, it's not possible. If the tracker is enough smart and in the case especially if we are using the secret key, I mean the single key for encryption and decryption, so somehow if they have tracked your that key, so they can easily read your message and they can again encrypt the message and they can send to the receiver, and receiver will not have any impression like that. Somebody in between that, they have tracked the message and they have read the message, they have used that, they have re-encrypted that. But in the case of quantum encryption, it's not possible, because the moment they will trap any one of the bit phases and they will try to alter or read like that, all the bits phases or shift will be changed, and automatically the message form will also change. So here we are using the photons, and especially this technique we are using when we are passing the key from the sender to receiver, either in the private key or in the public private key. I mean in the case of secret key or either in the case of public private key, like that. So that we say like that, quantum key distribution, when we distribute the key from the sender to receiver. Because when we are using the pair key concept to encrypt and decrypt, pair key means public and private one, to encrypt and decrypt message, so what we are using, the private key that the sender is keeping with himself, but the public key he is transmitting to all the persons whom they want to send the messages. So more than one person having the same key, like that way. And here, if we are using the quantums, we are using the same technique. But here, the phenomena is little bit more advanced, or like that, more, it's a crucial like that way. So it's not easy that anyone can have this trap this one, or even if they have trapped that, the final value that the photons is representing will automatically get altered and changed like that. Now next please. Now they are telling the same thing, just little bit of how they are working. So here we are creating a key by using a some series of the bits 0 or 1 like that way, and they will have in the different phases. Maybe one bit I say like that 10% zero polarity, 90% one polarity, another bit 50% zero polarity, 50% one polarity like that way. So we create a series of bit with the different polarity and then transmit using the polarization of an individual. I mean, by maintaining their phases or shift like that, we transmit those photons over the optical fiber cables. So the this process relies on the fundamental law of the physics. Here, the fundamental law of physics, they are telling the a split theory. A split theory like telling like that, if you are making any hole in the paper like that and we are passing the light and then we are observing that, then their phenomena is different. If we are not observing that, then their phenomena is different. So that same thing happening here like that. If we are observing the any photons, they will either in the 0 or 1 state. But if we are not observing these photons, they will be in the form of some percentage of the 0 or some percentage of the 1. So that's telling that they are using the fundamental law of the physics. Now, cloning is not possible. It's totally impossible to make the clone of that. Now, observation disturbance. This observation disturbance we are using to break the entanglement of the bits like that way. Or sometime to adjust the phases of the bits of like that way. How we can change the shift or phases of the bits. So we are using the sum of the observation methods, and mainly we have the 5 kind of the observation methods, either by increasing the temperature or by shaking them or like that freezing them. So one of the observation method we use to adjust their shifting like that way. So they are telling like that how they can change, but this is not easy for them. Now next please. Now, the first part that we have completed that, the encryption, and what is the encryption, and we have also discussed like that, how it is going to be implemented by using the classical computers and how it is going to be implemented by using the quantum computers or quantum techniques. Now, the digital signature. Here it is the mathematical techniques. Mathematical technique is some of the functions we have or hashing like that we have to validate the authenticity and integrity of the message, software and digital documents. How we authenticate that? So later we'll come to know it is the one form of the key distribution like the public and private key distribution that we are using, and that they are ensuring that the message is authenticated or the purity of the message is same as it was pure like that way. So this method we are using while we are transforming the sending or transforming the message from one places to another place or one user to another user. A little bit previous please. Yeah. Secondary, it also give an impression like that the sender cannot deny that they have not sent the message. So some sort of the impression they are giving like that, no, what the message I am receiving that must has been sent by the sender like that. Next please. Yeah. Just a figure, just figure that, give the figure, yeah. So check that how this is going to be work and implement like that way. Here we are passing two things to the receiver. So we have the original message. That message we are hashing that. I mean, we are applying some sort of mathematical functions or procedures to convert the plain text into the ciphertext. After that, that one we are using the encrypting by using the private key. So the moment we got the private key, so we are using the technique of the public and private key, that we have the asymmetric methods of the encryptions. And the sign one, if we have encrypted the hash one value of the message, that is called the digital signature. Now, original message as well as the digital signature, we are passing these two things to the receiver. Receiver, what they are doing after receiving this, the encrypted one, I mean the digital signature and the original form of the message, then again they apply their one hash on the original form of the message, as well as they are decrypting the digital signature by using the public key, and after that they are comparing that. If the message is 100% correct, so they find that no, what the message we are getting, that has not been altered anyone with, or that has not read by anyone. Please. Next, please. So working, they are telling that what sort of operation we are using that here. So first we are hashing the message. Hashing means we are converting a plain text into the encrypted text or the unreadable format of that. That is also called the fingerprint. After the encryption one, the signer using the private key, and after that they are generating the encrypted message, that is called the digital signature. Now third things verification happen, that happen at the receiver side. Receiver side, after receiving the message, they apply their hash function, and they get the new version of the hash value of the original message, as well as the decrypt the digital signature that they have received sent by the sender, and the decrypted one and the applied hash version of the message, they compare that. If they find matching is okay, they find that message is correct and in the pure form of that. Next, please. Now key generations, here we have. Sender generate the unique pair of the key. One is called private key and the public. The private key, that is kept secret, I mean that is kept by the sender, while the public key, that is shared to all the people they willing to, or they are intended to receive the message. Second operation we are doing, we are hashing the message. What the message we want to say, we hash that. While the hashing, we apply the different methods of the algorithms. Like that, one of the method we have given, SHA 256. We'll come to know like that. We have earlier we have the 16-bit of the hashing, then become 32-bit of the hashing, then 64-bit of the hashing, then 128-bit of the hashing. Now we are using the 256-bit of the hashing. Here, mostly if we study this hashing function, you will find that it is the combination of the XOR function, NAND function, NAND gate, AND gate, XOR gate, NOR gate, and the combination of that. So how many gates, how many bits we are feeding to them, and how we are generating the final XOR or NOR, then they will deciding like that which alphabet will be shifted with which alphabet. So here we are using the 256 bit of the encryption. More bit indicate like that the more complex of the encryption. I mean, it's giving the more difficulty the tracker who can track the information and who can change the information. A hashing function that we are using of the less bit like 64 bit or like 128 bit, they will have chances by the hacker to applying the brute force. Sometime they are able to find that the key, and after once they find the key, they read the message, they encrypt the message, and they send to the sender like that way. So that way they can trap that. So here they are telling that generally the hash function we are generating, we want to make it more secure, more reliable, and full of integrity. So we are using the 256. 2 years, 3 years before, even the SBI, they were using the 128 bit of the encryption. But nowadays, they are using the 256 bit of encryption. But yes, of course, we have the one bank, HDFC, that is from the beginning. I mean, when they have started, just after few years of that, they have started to use the 256 bit of the encryption. Now the signature creation. How the signature created? Once we hash the original message, then after we encrypt that hash one by using the private key, and that the encrypted version is called the digital signature. So after that, we send the digital signature as well as the original message to the sender. Sometimes we say like that, what the signature we have created, that we attach with the message, and we send the simultaneously both to the sender. Sender, upon getting the message, they de-attach the signature. They apply the decryption on the signature by using their public key, as well as they apply their hash function to the message, and finally they verify how, by matching that. If the matching proper, okay, they find that this is the correct. Nowadays we have also the certifying authority. So certifying authority, what they do, first they certify the sender. So somehow if we communicate to them, we have some sort of the registration, we have the some sort of the fee. Even you can find on the Google website like that. Many of the certifying authority we have in India also like that way. So if you pay some sort of the things, so before the sending your documents, you can certify with them. So in that case, the certifying authority, they will give a public key to you, and they will give the private key to the person you are sending the information. In normal way, if we are not getting involved the certifying authority, private key used by the sender to encrypt the message, and public key used by the receiver to decrypt the message. But once the certifying authority we get involved, say they give the public key to the sender, and we sender decrypt our messages, or we decrypt the hash value of our messages by using the public key, and then we send to that. And then what the key has been given by the certifying authority to the receiver, they use that private key and they decrypt that, and finally they match that. But in general, normal concept without getting involved, private key used by the sender and public key used by the receiver. Now next please. So here the common phenomena they are telling like that. So here we are using the public infrastructure. Once they are telling the public infrastructure, so here we have the pair of the key. One is the private, one is the public key, like that. So that we use to ensure the security as well as trust. Trust means non-repudiation. If we talk about the security, we have 3-4 factors: authentication, authorizations, non-repudiations. We have like that. Now next they are telling the digital certificate. So an electronic certificate often issued by the certifying authority. We have discussed about that prove the identity of the signer and is linked to the public key. They trust they certify the sender if what the message they are sending, that we have certified, and the message what you are getting, that they are coming with that sender like that. Application of the digital certificates, so used for digitally signing the government document like income tax returns or the e-procurement and tendering, especially the government agency. If they are receiving some of the documents, they are getting signed. Signing means they have one more person as a witness for them. No, I have signed this and they have sent to. So later you cannot deny, no, I have not filed this tender or I have not submitted this document like that. Now we are coming the classical concept as well as the quantum concept of that. So classical concept and quantum concept, both we are using the PKI infrastructure. I mean the public and private key infrastructures. But in the classical one, here the hash function what we are using, that is generated by our classical computers, not by the quantum computers. But in the case of quantum computer, the hash function that is generated by the quantum computer. And the advantage disadvantage of that, we'll discuss the latter phases of that. But one advantage we want to tell you like that, if you are using the classical computer and if you are using the advanced methods of the hashing, then it takes more time to hash the sum of the message because its computing power is limited. But if you are using the quantum computer to hash the sum of the message by using the some advanced method of the hashing function, that is taking less time because quantum computing speed is much more than the classical computing. When we have joined the conference, Sibli ma'am also were there. So they were telling like that what the quantum computer can do in 2 years, the 2 hours, the classical computer need 10 years to complete that way. So we can imagine that what is the speed of the quantum computer and where our this classical computer is standing in front of the quantum computing. Now the working mechanism we are telling like that way. So unlike the classical, sorry. So please, just a little bit before, ma'am, before come to the classical one. Little bit more. Yeah. So here classical. Here we are using the hash function, and after that hashing, what they are creating, that is that we are calling that a message digest. And after the hashing and encrypted that we say the digital signature. So sender, they are using the private key to create the digital signature, and after that they sending the original message as well as the digital signature to the receiver. The recipient then verifying the signature by applying their public key to decrypt the signature as well as by applying the hash function to hash the original message and then matching that. So here just will come to that picture that is showing the working mechanism. Here we have Alice and Bob. I think all of us are familiar with this story. Alice, Bob, and Ehulai that way. 3 person involved in the data. If we are going to be sent from the one place to another place, one person to another person. So Alice, that is the sender, and Bob, that is the receiver, and in between we have one person named Eve, that is the tracker. I mean that trap the things like that way. So in the case of classical computing and quantum computing, the working mechanism is same. Only the hashing mechanism we are like that getting, one of the classical and one is the quantum. So Alice, they are getting the message. After that, they are decrypting the message or they are applying the hash. After that, they are applying their private key and they are encrypting that. So after finally, they are generating the digital signature. Now the ally is sending the digital signature as well as the message aimed to the Bob. Bob, after receiving the message as well as the digital signature, sorry, sorry for that, they are applying their public key to decrypt the signature as well as they are applying their hash to generate the hash value of that message digest, and they are comparing that. If comparison is okay, I mean matching is perfect, okay, 100%, then they find okay, our message is okay, and no one has trapped and no one has changed that. Next, please. Now we are coming to the quantum. So unlike the classical methods that rely on the computational difficulty, I mean the quantum computer, so here we have the protocols based fundamental principle of the quantum physics. Against coming physics means we are dealing with the photons and the bits phases and their polarity like that way. So say that no cloning theorem and quantum entanglement. Entanglement already we have discussed like that way. So if you have a series of bits with the different phases or with the different polarity, and if we are changing one of them, so the other also they get changed. So final value what we will get, so that will be not represent our original version like that. So any person if they are trying to track that and trying to read that, so of course this photon is that much sensitive like that way, they will get changed. If even one of the photons shift get changed, other photons they will also get changed like that. So this is the reason they are telling that here cloning is not possible like that way and tracking is not possible like that way. Even if somebody tried hello. Okay, shall I stop or shall I start? Continue? Okay. So here we are using the quantum machine to provide the secure verifiable electronic signature that are resistant. Resistant means that if somebody trying to trap them and change that, so this provide the more resistant. I mean more difficult to trap and change that. So tampering is not possible in the case of the quantum computing. One thing's already I have told that if we are using the advanced hashing functions, so classical computer they are taking more time, and this the quantum computer they are taking the less. Next, please. Yeah. So working, the infrastructure is same. They are also using the PKI infrastructure. I mean the public key and private key like that way. And same way, private key used by the sender to encrypt the hash value. I mean the message digest to create the digital signature, and then they send to the receiver. Receiver they hash the message as well as to decrypt the signature, and they match on that. Here they are using the for this purpose they are using the one of the quantum key distribution. They distribute the key. So quantum key distribution of course involved means passing this key by using the photons. I mean using these optical fiber cables and making the different phases of the series of the 0 and 1 like that way and passing that. So that is a quantum key distribution. So that provide the established and the secure mechanism to pass the key without getting it trapped anymore. Verification same happens like that way. The receiver after receiving this message digest, they apply their hash as well as they apply their public key to decrypt the signature, and after that they message and they compare that. If they find it compare is okay, no difference in that, they find message is okay. I mean as pure as it was the original. Next, please. Now we are going to discuss the latest trends. We have discussed the common principle of the encryption, common principle of the digital signature. We have also discussed how the classical computer playing a role in the area of encryption description and quantum computing playing a role in area of encryption decryption, I mean the cryptography, as well as how classical computer and quantum computer is playing a role in digital signature. Now we are coming to the latest trends. So when we are using the different kind of the ciphering algorithms like the blockchain we have, like we have the crypto agility we have like that way, or identity verification we have like that way. So now these classical computers, okay, since it's a common and now it's going to be used widely by the people, so the technology that we are using to create something, same technology used by the tracker to catch that things or to trap that thing. So due to that, the various of the mechanisms and the research and the tools and technology needs to be deduced and derived and produced like that way. How those things can be stopped like that way. So here there is a very growing demand in the cryptography like that. What could be the better algorithm? What could be the best procedure? What could be the better functions through that our encryption decryption could be faster, as well as if the data or the key is going to be passed from one place to another place, it should be safe, reliable, and intact as it was the original like that. So in case of in area of the cryptography as well as in the area of the digital signature, the many of the changes has been happened, but still the changes are required to provide a realistic, reliable, secure, and intact solution. They can provide the best solution to perform this. Now next one, please. Next slide. So latest trend in the area of post-quantum cryptography. Now it is telling that post-quantum cryptography. Once we have introduced anything by using the classical computer, we know that their speed is limited. A speed, I mean the calculation speed, computation speed limited. Now the quantum computer we have evolved. So it's easy and possible to break the key by using the quantum computing power over that classical computing power. I mean, a message has been hashed by using the function using the classical computer can be deciphered, can be break, can be judged, can be identified by using the quantum computing power like that. So they are telling that post-quantum cryptography, I mean some sort of cryptography we need to evolve so that even by using the computing power of the quantum computing, our cryptography will be safe, secure, and reliable. Now the hybrid cryptography. These days, these days we are using some of the methods or some of the cryptographic techniques or hashing by using the classical computer, or some of the methods or the technique by using the quantum computer. So that's a hybrid age we are using. So in this hybrid age, what should be measured, or what should be technique, or what should be mechanism, so that we will be able to develop a cryptographic techniques or the functions or methods that will be compatible for both the classical computer methods as well as the quantum computer methods. First thing. Second thing, that will be reliable, safe, and secure both for the classical computing methods as well as the quantum computing method. So that is the hybrid cryptography they are telling. Hybrid means we are using the technique of the quantum computing as well as the classical computing. Here crypto agility we are dealing that way. So again it's some sort of the quantum and this classical we have like that way. So here generally we try to find out the area where we have little bit chances and even the some percentage of chances where the information can be read or can be tracked or can be cipher or decipher like that. Now the area of advanced key management, we have the secret key and we have the public and private key. So again, how the different mechanisms we can use like that way. first we were using the public key, private key. Now certifying authority has come in between that. So now what can be more advanced way or mechanism? In that way we can able to generate the advanced methods of key generation, or advanced method of securing the key, or advanced method of transmitting the key from the sender to receiver. Now the privacy enhancing technology like that way, especially when we are putting our private data, I mean the personal data. Many times we upload our personal data to the government website or the bank site, or the many people they are asking like that way. So some sort of encryption decryption we are using like that way, but we are not using the advanced and sophisticated method when we are using our that kind of information from the sender to the receiver like that way. So just to protect that kind of the information, what sort of technology or mechanism we can develop like that way. So that is also one of the area we have. Now already we know that AI, artificial intelligence, that is the copying and mimicking that computing power or thinking power or responding habits of the human like that way. So that is the AI. Then after that we are coming that of machine learning. We have deep learning. We have actually deep learning is the subset of the machine learning. Machine learning is the subset of the AI. AI is the artificial intelligence that we are telling the way of thinking, responding, and behaving like that way for the any of the actions and reaction like that way. So that we have introduced to the machine, and that we have put into the machine. They start doing like that way. We have very big debate over that whether we should put our the human analysis power to the machine or not, or if we are putting that how much percentage we should put or not. It's a some sort kind of the debate we have like that. But of course, the many of the country or even we people are using the AI and the machine learning and deep learning to integrate our works and to get our works faster and like that correct and like that efficient manner. So again, one of the things like that way, how we can use that AI power or machine learning power or deep learning power in area of the cryptography and in area of the digital signature like that. Next. Yeah. Latest trend in the digital signature. So integration in the blockchain, mostly 90%. Here the encryption, decryption, and sending of that we are using the blockchain methods like that. So how the other technique can be integrated with them to make it more stronger, more advanced, more faster like that way. Now, can we use the biometric method of authentication when we are sending our information from one place to another place like that way? Biometric method of authentication, we have the fingertip, we have the facial scan, we have eye scan or cornea scan like that way. Sometime also we are using the voice recognition like that way. So can we use these techniques while creating our key, or while ciphering the message, or while encrypting the message? So they are also thinking for that way. Then the mobile first solution. Nowadays, all of us, or most of us, 99% people like that way, the young generation. I'm not telling about the old people or aged people like that way. They are using the mobile. We can say that mobile, of course, has replaced our the laptop and the desktop like that way. So can we use the mobile to encrypt, decrypt the messages, or can we use our mobile to generate the key, secret key, or the private key, or the public key, or can we use our mobile to generate the hash function? So again, that are the trends we have like that way. Many of the researchers they are working over that. They are using the mobile, or they are trying to deploy the mobile techniques and powers to area of encryption and decryption. Again, AI powered of verification and analysis. If we have generated any one of the methods, either for the encryption or decryption or the digital certificate, so that go for the analysis. This is also sometime debate we have like that. Once we are putting the analysis, there is chances like that to make it public, and once it become the public, then our scenario and our algorithms or our mechanism will be like known to all them, so that will be have easy prone to make attack like that. But this is the procedure. Once we have developed any of the hashing functions or the any of the program or software to generate the key, either the secret key or the PKI infrastructure, first we have to send for the analysis. They do the analysis. After that, they say it's okay. It can be bring to the public domain for the using. Then after it come to the using like that. So they are telling like that how to get involved the AI power in this area at the time of analysis and doing the analysis. Now, a regulatory authority we have. US already had developed a regulatory authority in the late 2024, or you can say early in 2025. That regulatory had defined the new set of the policy and standard like that to generate the public key, private key, as well as for the method of encryption and decryption. There is a one problem with the US like that. What they generate, first they keep for their one usage. Once they find that they have developed another method for the same work, then the previous method they release to the market like that. But what we can say like that way, either we can create the our one things or we have to follow the US things. But nowadays India has started to create their own things, especially in the space and the other area also, in the defense area also. They are following, but they are not following that much. They are following very less and then creating their own things itself like that way. So regulatory authority US has developed for the new generation or new era of the encryption decryption as well the digital certificate like that. Now, remote online notarization. They are telling that how we can deploy these things in the notarization. If if we go for the notary, we need to go to the court, and after that we have to create authentic document by getting involved the lawyer and the judge like that, when notary judge we say like that. They are telling that can we make a secure methods through that we can create a authenticated document. They can verify that what we are putting that is the correct and that is the under law like that way. Likewise, the notary document. So they are also telling that the area of the research where we are going to deal like that way, can we develop such kind of the things. Now the payment integration. Generally, now the payment integration happen between the one party and the second party, I mean the payer or the receiver like that way. But sometime more of the person involved like that way, like that A paying to B paying to C paying to D like that way, circular way. So can we have that kind of the security mechanism? They can ensure and they can check and they can verify, as well as later they can prove that the thing happened in that. So they are also telling about that. Now next please. Yeah. Now the research area. So research area in the cryptography and digital signature focus on these quantum resistant algorithms, then the privacy preserving protocols and blockchain applications. Already we have discussed about that way. Other things we have like that, exploring the usage of the cryptographic, the game theory. Next please. Next please. Developing the methods of the crypto analysis like that. Now this we have discussed the things related to the cryptography and the digital signature. We also try to focus out the latest trend as well as the research area available in this field like that. So next we have the question around like that way. If you have the doubt, you can raise like that. It's not possible to resolve all the doubts now. So I'll be request the Sibli ma'am to send my email to them so that a later even if you have anyone of doubt related to this, you can ask me like that. So anyone any doubt you have like that?
Hello.
Thank you, sir.
Okay, ma'am.
Now,
Hello,
participants can ask the questions.
ma'am.
Uh,
Shall I ask a question?
yes, sir.
Sir, sir
Tell,
has mentioned regarding the digital signature within quantum. So you have
yes,
mentioned with the quantum, everything will be like so secured. But what is about like elliptic curve cryptography concept, which is much more better than the quantum computing for the generating the digital signature?
sir, if you are taking about the electric, I mean, think you are telling about the light. So also in the
Yes, sir.
case of quantum, sir, we are using the photons. Photon is the source of the light. So you are talking similar to me. So what you are telling, that's possible and nice.
No, no, sir. But the thing is, related with the quantum computing to generate the digital signature, there is like more type of and hacking and all those things are being like much familiar. People usually can able to trace out the cryptography values. But when it is comes with an elliptical curve model of mathematics which is linked with this cryptography, where like the amount of hacking details are being less. So in what way we can able to tell like this quantum computing which is related with the cryptography is much better for the security purposes?
Sir, one thing I would like to tell about the quantum computing. First of all, it has not come into the exposure of all of us. Very few of us have worked on the quantum computing. I do not know. Even I have not worked, sir. Only we have the theoretical concept of that. And
Okay.
if you are comparing in that if you are comparing in that way, and since we have not the practical exposure of that, so this time I am not able to I am not able to tell clearly about that whether this will be more better or secure, or whether that will be more better or secure. Even what you are telling that, even I am accepting that way. But once we will have the complete exposure of the quantum computing, like what we are using the classical computer, then we will able to compare and able to tell that no, this will have the more secure and this will have the less secure. So current moment of time, what you are telling like that way, that's the correct. We are telling that. But since the quantum computing, still it's in the stage of evaluation. Google had developed, IBM have developed, and other have developed, but they have not completely exposure their working mechanism. Some of the working some of the working mechanism based upon the light, some of the working mechanism based upon the magnet, and some of the working mechanism based upon the electromagnetic waves like that. So currently we are not able to tell clearly like that that will be better or this will be better. So that is the reason we are going in the hybrid mode. Hybrid mode means we are working on both the mode and we are trying to find out that which will be better, which will be reliable, which will be little bit user friendly.
Thank you, sir. Thanks, sir.
Okay.
Thank you.
Okay. Anyone else, ma'am?
I have one doubt, sir.
Please, ma'am.
Actually, digital signatures and there are digital certificate. Actual use how digital certificate help us in there is no encryption decryption happening. That there is
Ma'am,
encryption
if we
decryption
have the
happening.
Yeah, if we have the electronic signature and digital signature, electronic signature generally happen between the two person. I mean the sender and receiver. Many time we use our thumb impression just to make it okay like that. Okay, this the document and this information what we are sending, we are the part of that way. But if we are coming to this digital certificate, so digital certificate, we have the certifying authority. If it is coming to the electronic signature, here this encryption decryption is not. But sometime we have the government approved like that agencies like that who verify the Aadhaar, or like that who verify the PAN card. So that kind we have one person involved in between us, and they are authenticating that no, this is the correct user, and they are not applying the encryption and decryption. But ma'am, current era, even what the message we are sending by email, or what the message we are sending by the WhatsApp, that is going to be encrypt and decrypt like that way. So for my opinion, as per my opinion, we do not have any digital certifying authority. They are not encrypting and decrypting the information. If they are authorizing the sender like that, you are sending the message to this receiver, to this sender like that, as per my knowledge.
Okay, sir. Thank you.
Okay,
And
welcome.
I got one doubt. If we are using a key distributor, we are using public key for encryption and private key for decryption. And in the other
Correct.
case, why that happened? That change happened, sir.
No, ma'am. If you are not using any, if you are not getting any certifying authority involved, then the private key used by the sender to encrypt the message, and the public key used by the receiver to decrypt the message. And if you are asking the reason behind that, why only the private key is going to be used by the sender to encrypt the message, and why the public key is going to be used by the receiver to decrypt the message, current scenario I am not able to tell like that way. But what the standard is going to be followed widely, that we are telling like that way. Mechanism behind, sorry, reason behind that I am not able to say. Maybe later, after doing more study, and what the you have trick in my mind ki why this is happening like that, only the private key is going to be used by the sender to encrypt, and the public key is going used by the receiver to decrypt. Current moment, I do not have some concrete information about this.
Thank you, sir. Any doubt for other participants, kindly come forward. He's a very resourceful person with so much years of experience and many publications. He's a friend of me, and we had two programs together. He's a HPC master trainer, and also we got option to attend HIPC conference in Bangalore last December. And he's a very humankind person, and he knows so many examples, and he can relate that to real life. Difficult theories can be related to real life by him. Okay. Thank you, participants, for the patient listening, and thank you, Vinod sir, for being our
Thank
resource person and delivering this much
you.
details. And first time, I also am deeply thinking about quantum computing and post quantum
Please.
cryptography and keys distribution, etc. Thank you once again.
Okay,
I would
thank you, ma'am. Thanks a lot to all of you for being with me. Have a nice
I'm
time.
inviting any of the participants can give the feedback also.
Please.
Greetings, one and all. I take this opportunity to thank Dr. Binod Kumar for sharing his valuable knowledge and insights with us. Sir, your session was truly enlightening, especially the way you explained complex concepts like quantum techniques in digital signature and the latest research areas in cryptography. You helped us understand not just the fundamentals, but also how these technologies are shaping the future of secure communication. Once again, on behalf of Government Engineering College Wayanad, thank you, sir, for your time and effort in making today's session so enriching. Thank you, sir.
Thank you, Navin sir. Thanks a lot. Please.
Thank you. Thank you, sir.
Okay, ma'am.
I'm inviting the next speaker. Before that, we can have a 5 minutes break, and we can start the session sharp 7:30. Thank you, participants.
Thank you, Simli ma'am. I'm leaving
Thank
now.
you. We
Okay.
can meet again, sir.
Okay.
Hope to
Thank you,
meet
ma'am.
you soon.
Thanks a lot. Please.
Okay. Welcome, Jagdeep sir. Kindly present your screen, sir. Hi. Not hearing, sir.
Hello, ma'am.
Hello. Good afternoon, sir.
Yeah. How are you, ma'am?
I'm fine.
Yeah.
Yeah, I hope you reached home safely.
Right.
Okay.
So, am I audible?
Yeah,
Perfect.
sir. Yeah.
Okay.
I think
So,
we can start with a small introduction. I'm inviting my coordinator, Dr. Danya, to speak few words about Dr. Jagdeep Singh. Welcome, Danya, and welcome, sir.
Thank you, ma'am. Dear participants, for our next session on PK and secure protocols, the resource person is Dr. Jagdeep Singh. Sir is currently an assistant professor in the Department of Computer Science and Engineering at San Longawal Institute of Engineering Technology, Punjab. Sir has received his PhD in computer engineering from the University of Delhi, India. His research interests include artificial intelligence, machine learning, delay-tolerant networks, and cybersecurity. Sir is also an ACC certified master trainer in high-performance computing. Dr. Singh has published research papers in prestigious journals such as IEEE Internet of Things, Journal of Ambient Intelligence and Humanized Computing, IET, International Journal of Communication Systems, and Journal of the Internet of Things. And also, he has presented his research at several international practice conferences, including IEEE ICC, GLOBCOM, ANA, and IEEE CITS. There is a senior member of IEEE and the Indian National Academy of Engineering, INAE. Also, there is a member of the International Association of Engineers. Sir reviews papers for leading journals, including IEEE Internet of Things, Transactions on Information Forensics and Security, IEEE Transactions on Green Communications and Networking, IEEE Access, Transactions on Emerging Telecommunication Technologies, IJCS Wiley, and Wireless Personal Communication. Sir is the recipient of Shastri Conference and Lecture Series grant for the year 2021-22. Uh, and also, Sir was the team leader of Team EMMET, in which he led the team to victory in the prototype stage ideation stage of the open competition for Indian Web Browser Development Challenge, organized by the Ministry of Electronics and Information Technology, Government of India, which bagged a prize of $1,000. Sir, we are happy to invite you as the resource person for the day. I welcome you to FDP.
So thank you so much. Thank you for the nice introduction, ma'am.
Welcome.
First of all, I would like to thank you, the organizer and coordinator Sebli Joseph, for inviting me and to share the few words about the ATAL FDP cybersecurity bootcamps in this session. So I'm going to share my screen first. Ma'am, I think my screen is visible to you.
Yes, sir. Yes, sir.
Okay. So dear participant, this is the second day of the faculty development program, ATAL sponsored faculty development program on cyber bootcamps. The title of the session is Public Key Infrastructure and Secure Protocols. Myself, Dr. Jagdeep Singh, Assistant Professor in the SLITE Longowal. It's a CFTI, Government Funded Technical Institution under Ministry of Education. So I will cover in this session the public key infrastructure in real sense, what we are dealing with the PKI and how we are using PKI in the real life. So I will discuss first the public key infrastructure introduction, and then I will cover the secure protocols, particularly to the cyber boot camps or cyber security real case scenarios. And in the middle part of this particular session, the SSH protocol, secure socket cell. And in the last, we will discuss the emerging PKI use cases in real life. Challenges and future direction we will discuss, because in the research, multiple dimensions of the PKI are available. So all this we will cover in this particular session. As this figure illustrates the PKI, in this figure we are seeing this, the public key infrastructure. Here in this figure we are seeing that there is a client and a server, and a pathway is available, a transmission medium is available with few captions at the client side, at the server side, and public key and private key both are available. When a client want to send a particular message to a server, he first encrypt the packet, then transfer the packet over the medium with the help of public key of the sender, of the receiver, and private key of the sender, and then this will become an encrypted packet. And this is called a ciphertext. I think all of you are aware about the cipher and the encryption keywords. So PKI is a total infrastructure that composes the clients, servers, public key, private key, and other particular parts. Here, Daffy and Yosemite, two keywords are available in this screen. So public key encryption with more details like bugs cannot be read it, because the packet, it directly encrypt and then transmit the packet. This is the first rule of the cyber security. In this particular work, we will discuss in detail about the public key, private key, secure socket layer, and the public key encryption in more of the data. So digital transformation has expanded attack surfaces exponentially. So the main question is, why PKI we need? Digital transformation we are using nowadays very exponential manner. So secure communication requires trust, authentication, and non-repudiation, because these are the pillar of the secure communication. Today, PKI is the backbone of these goals. I think all of you are aware about the PKI, that authentic identity binding, confidentiality, integrity of the communication, and scalable trust management across organizations. So PKI ensures all three parameters here are listed. So these are the main goals of the backbone that PKI consists. If we talk about the historical evaluation of this particular public key infrastructure, so Whitfield Diffie and Martin Hellman introduced this public key cryptography in 1976. And in the 1990, the emergence of X.509 certificate and SSL certificate for securing web traffic. In 2000s, PKI became central to e-commerce, e-governance, and VPNs. Modern PKI applications we are using right now in in real life for digital signatures, for zero trust architectures, and for securing our emails. So all this cyber security concern is we need PKI as backbone. So these are the basic applications for the PKI enabled secure services. Now, for a particular application, we are using PKI, that's okay. But what are the key components of the PKI? As a general sense, these 5 are the core components of PKI. Here, certificate authority as a CA, registration authority, certificate repository, subscribers, relaying parties. These 5 are the main component of PKI, where certificate authority means issues and manages digital certificates. Registration authority, it means verify entity identity before certificate issuance. And similarly, subscriber are the end entities using certificates. Relaying parties are the entities trusting certificate for secure transactions. So these are the main component of public key infrastructure. Now in this figure, we are able to see this, how PKI works. So key concepts and processes are illustrated in this particular figure, where Alice and Bob both are available for a particular transmission. Alice wants to send a message and Bob wants to receive a particular message from the Alice. So message encrypted with Bob's public key, signed, and Alice private key. As the public key infrastructure main thumb rule is, sender's private key and receiver public key both are aligned, and then message will be encrypted. So you can see here, Alice private key, Bob private key, both are available, and at the transmission medium, both public keys are available and public keys are open to all. So Alice can access Bob's public key and Bob's can access Alice public key. If Alice wants to transmit something, so Alice use the private key of Alice and public key of Bob, then message encrypted with Alice private key and then send over to the transmission medium, and it consists of particular cipher with a hash or a timestamp. Then it will be transmitted, and then there will be no problem at all during the transmission. When the Bob receives, message decrypt with Bob's private key and Alice public key. So it will be a great transmission type that message is securely transmitted from Alice to Bob. There will be no problem and there will be no interception between the transmission, because the message is already encrypted. There is no such kind of alteration can be possible in normal sense. So this is how PKI works in real sense. So I have used two points here, the public key and the private key, right? So there is a key pairs we need. For a particular implementation of the PKI infrastructure, so public key is shared with others and private key kept secret and used for decryption or signing. So keys are mathematically related with infeasible to derive one from the other, because public key which is available for all and private key which is secret and used only with the owner, that means maybe at a sender or maybe receiver. So all this is the key pair of this public and private key pair. So digital certificates is another particular entity be discussed in this particular session, because digital certificates are using the PKI. So certificates bind a public key to an identity. In digital certificates, we are using X.509 standard. It's a very important format for digital certificates. And its certificate contains who is the owner of the certificate, what is the public key in that certificate, issuer and validity period, and signature of the issuing certificate authority. So all these kinds of the information are available in the digital certificate. And whenever you see this digital certificate, when you apply for the income certificate, residence certificate, and other kind of certificate like caste certificate, a digital signed document will be issued to you from the municipality, from the Tehsildar, from the district collector office. So digital certificate you can see anywhere with the public funded person authority. So the basic meaning here is X.509 particular standard or particular protocol we are using for digital certificate. So certifying authority, then intermediate certifying authority, and then end entity certificate will be generated. In a hierarchical model ensures because all this is available in X.509 certificate. So scalability, control, delegation of authority, simplified certificate revocation, all these features are available in our model. Root certificate authority trust anchors are embedded in browsers and OS. I want to tell you one thing. When I developed the Indian web browser for Government of India through Ministry of Electronics and IT, I embed our certificate in with the help of blockchain tokens. So root certificate authority trust anchors I have embedded in browsers because I developed the Indian web browser development. So I developed with the OS. I make changes in the OS and browser root code. So root certificate authority, all these are available in this particular work. So we need to ensure what is certificate and why we need this certificate in real sense. So in the certificate life cycle, these are the 5 key points: key generation, registration, validation, certificate issuance, installation and use, renewal and revocation. So all 5 are the certificate key points. And this is certificate revocation. Regions of the private key, change in subject information, end of employment or validity. These are the main regions when we revocate the certificate. And the mechanisms are the certificate revocation list, CRL, we are using for revocation purpose. Online certificate status protocol, all this OCSP and CRL we are using nowadays for certificate revocation. And you can use these mechanisms very easily with some kind of technical help. Trust models in PKI. This is you need when you deploy a PKI in your network. So hierarchical model, mass, bridge, and hybrid model. All these are the options when you need to deploy the trust models in the PKI. Basically depend on the CA, certificate authority. When we have single root certificate authority with multiple sub-certificate authority, then you can use hierarchical model. When you have multiple certificate authority and cross-certify each other, then you can use mass model. central bridge certificate authority connect multiple hierarchies, then bridge model will be a great help. And hybrid model, then you can combine the hierarchical model and mass model, trust relationship. So when you want to deploy the trust model in the PKI, then you have 4 options like this: hierarchical, mass, bridge, and hybrid. You can use any of these. In our companies, in enterprises, security is at most required. So PKI in enterprise security is related to real sense. So authentication of users, servers, devices, email encryptions, digital signatures, secure VPN, and remote access, device identity in IoT and as networks, secure software distribution via code signing. So all this is available in this particular PKI in enterprise security. This is one example of email security. You can see here, digital signature. You can see here, this certificate is valid. Okay, you can see here from and sender email, example of signed email. This signature is valid and trusted. There is no issue at all, because when the digital signature is valid, it means the message is trustworthy. So in real sense, nowadays we need a digitally signed emails. So I want to give one case study of 2011 of DigiNotar breach. DigiNotar breach is related with the certificate authority. So Dutch certificate authority was compromised by attackers. So fake certificates were issued for high profile domains like Google, for instance. And this DigiNotar breach, in this particular breach, it is used in man in middle attacks against Iranian users. So the result of this particular breach is, as all major browser revoked trust in DigiNotar, company declared bankruptcy and highlighted need for monitoring and certificate auditing. So this is one of the breach related to the certificate authority, where fake certificates were issued for high profiles domains. And Google is one of the best high profile domain in this sense. So I want to share this because breach is at high level. And due to this breach, all browsers, mostly all browsers, revoked trust in DigiNotar. So this is one of the case in 2011. Another case in 2017 related to Symantec PKI misissuance. Symantec issued unauthorized certificate and violating certificate authority forum rules. In this particular problem, the Google and Mozilla Firefox distrusted Symantec root certificate authority. And based on this misissuance, the impact was very high because millions of websites had to reissue their certificates and emphasized transparent monitoring by certificate transparency logs. So the impact was so high because millions of websites had to rework again in reissuance of the certificate. So the main point here is the certificate transparency is required. Why it is required? Main question is. So role of certificate transparency is main because this is introduced by Google to prevent CA misbehavior. Public append only log of all issued certificates, and mandatory for most modern browsers because this is really useful and mandatory for all the browsers. for public appended only log for all issued certificate, and it can prevent misbehavior by CA. As you all are aware that we are in 6G era, 5G advanced era, somewhat in the 6G. So with this 6G environment, there is a keyword called as zero trust architecture and PKI. PKI I have listed, but another keyword here is zero trust architecture, ZTA. So ZTA means never trust anyone, always verify. Never trust anyone, always verify. Multiple organizations, including Central Government of India, have adopted this ZT architecture in multiple organizations. Universities have also adopted this ZTA up to a certain level. And it's very good architecture for security enhancement. As per the certain, it is recommended that ZTA should be used in all levels and all organizations as much as possible. So PKI provides identity verification in zero trust environments. Every user and device must authentic via digital certificates. Because PKI is linked with the ZTO, so ZTA enforce least privilege access control. This is the pillar principle of the ZTA, that privilege level will be decided based on the person. Facilitate secure access service SACE implementation. So PKI and zero trust architecture both are really helpful in this particular time. Mainly in near future, PKI cloud native PKI services like AWS Certificate Manager, Automate, IoT device requires lightweight certificate provisioning EST, ACE. PKI ensures onboard firmware integrity, mutual authentication. All this is possible just because PKI in cloud and IoT environment we are using. We have multiple challenges in PKI in large deployments, because when you want to deploy the PKI at a large level in multiple organizations, so PKI will be facing a higher level of challenges, like scalability and certificate management overhead is the main challenge here, because certificate management at large level is itself a big problem to ourselves when we are deploying large. Secure storage of private keys, cross certification complexity, life cycle automation and policy enforcement. These four are the PKI challenges in large deployment. PKI, if we talk about the future of PKI post quantum cryptography, because in upcoming 5 to 10 years, we will see a great enhancement in cryptography, and that one is from the post quantum PQC cryptography. Now, in near future, we will see the quantum computers threaten RSA and elliptical curve cryptography algorithms. So post-quantum PKI research explores the alternatives like lattice-based, hash-based signatures. And this is the future of PKI. Transition strategy may be involved. We can use hybrid certificates and algorithms. So in some sense, I can say that public key infrastructure, the future of this PKI is related with the PQC, post-quantum cryptography. Now move on to the next session, next part of this session. That is the title as given me from the organizer, that PKI and secure protocols. Because if we summarize the PKI, public key infrastructure, means you need a particular infrastructure, that one is secure in all sense, from the sender side to the receiver side. The transmission medium is so secure that the message should be encrypted and no one can alter during the transmission. We can use certificate authority, we can use others medium like digital certificates and other kind of solutions for secure transmission from one end to another end. So there is a particular need that we need to use secure protocols. Secure protocols, what does it means, the secure protocol? So secure protocol define standardized rules to protect data communication. Why we need secure protocol? Secure protocol gives us the confidentiality, integrity, authentication, CIA as the most important pillar of this network security. And another fourth one is non-repudiation. So CIA principle is the main objective to use the secure protocols. So you can use the CIAN non-repudiation. So built using cryptographic primitives and PKI based identity management. Secure protocol are very essential for all of us. In protocol designing, actually I have worked in protocol designing since 2017. The core security principles in protocol design are four. First one is least privilege, second one is defense in depth, third one is perfect forward secrecy, and fourth one is replay resistance. Least privilege means only necessary access will be given to the users at what level they are. Defense in depth, layered encryption and authentication is going to perform on the layer basis. Perfect forward secrecy means session key independent of the long-term keys. And replay resistance, it's a very good initiative, and timestamps and nonsense prevent reuse of old sessions. So we need to understand this SSL, secure socket layer, and TLS, transport layer security. Actually, in 1995, Netscape developed this secure socket layer, SSL, and later on this evolved as a transport layer security, TLS. So we are using SSL, TLS, both as a keyword, SSL, TLS, and nowadays we are using TLS mostly, and this provides confidentiality and integrity between client and server. And it operates between application layer and transport layer. So TLS handshake mechanism steps are available in this screen. You can see in the first step, client hello. It means supported the cipher suits random nouns. Step 2, server hello. Chosen cipher suit certificates. Step 3, key exchange using RSA. Step 4 is session key generation. Authentication and MAC verification is the last step of the TLS handshake mechanism. TLS 1.3 improvements. TLS 1.3 is the improvement version of the TLS. Here in this particular improvements of TLS is it reduced handshake latency, removed obsolete algorithm, enforced perfect forward secrecy, early data support with replay protection mechanisms. So all these are the improvements of TLS 1.3. TLS cipher suits It means the defining the encryption, key exchange, MAC algorithm used in this session. You can see the example of the TLS like this in the screen. And this is the breakdown of this example. That's the first part of this example is ECDHE means key exchange, then authentication, then encryption, and then last one is hash function. Or you can see like this. This is a MAC available in SHA-384 format. So one of the important case study related to this is available in your screen, that is available from the 2014, and it is discovered in OpenSSL TLS heartbeat extension. And attackers in this particular vulnerability, heartbleed vulnerability, is publicly available, where attackers could read up to 64 KB of server memory per request. Private keys and user data were exposed in this particular vulnerability. So the main lessons is we need to validate input buffer boundaries and perform continuous security auditing. Case study another regarding this, the Poodle attack in 2014. So the padding Oracle on downgraded legacy encryption. This is the Poodle padding Oracle on downgraded legacy encryption, and it is exploited SSL 3.0 fallback and CBC padding flow, and it is allowed decryption of secure cookies. And this was the attack happened in 2014. The main mitigation approach was the disabling SSL 3.0 and weak cipher suits and enforced TLS 1.2 or higher. So this was the mitigation approach after we use this attack, the Poodle attack. Now we are aware of the TLS 1.3 and SSH. So if you want to deploy this SSH in real racks, so you need to understand the remote login and telnet and the file transmission by using tunneling in secure medium. So uses public key authentication and encrypted channels are essential. So understanding about this architecture is that one uses transport layer, user authentication layer, a connection layer. So all this is required because SSH architecture consists all this. Password based, public key based, and host based supported authentication is available in SSH. So you can apply anyone for the authentication. SSH key management, you can use key generation mechanism SSH, any RSA, ECDSA, or any ED25519, and you can store your key, authorized key, in this particular repository like /.ssh/authorized keys. And mismanagement leads to lateral movement and enterprise attacks. So one of the important compromise or a particular attack that was happened in 2022 regarding GitHub SSH key compromise. This is well-known compromise that was happened with the GitHub. So GitHub rotated its RSA SSH host keys after vulnerability exposure. Attacker could impersonate GitHub's infrastructure in man-in-the-middle attacks. So preventive action is migrated to ED25519 to ECDSA keys. So this was the preventive action, because when we have a particular key and when we move on from that key to another new one key, then this is the one of the best preventive action first instance. Demonstrated PKI key management is central to software supply chain security. So this was the very popular key compromise case study of 2022. Another one security label is IPsec. The network layer protocol suits secure IP communication. There are two main modes, transport mode and tunnel mode. Transport mode encrypts payload and tunnel mode encrypts entire IP packet. And these two modes works with both IPv4 and IPv6. So IPsec is available is a field in IP version v6 header, and you can easily get that header information from the hexadecimal information format of IP version v6. So IPsec components are the authentication header, encapsulating the security payload ESP and internet key exchange. So these are the key components of IPsec. Nowadays we are using VPNs in enterprises, right? And VPN is essential for a particular organization when we are dealing with the remote access and we want to work in a hybrid manner, then it is really required particular network. That one is VPN. So IPsec is essential for security purpose. So IPsec in enterprise VPNs used in site-to-site and remote access VPNs. PKI-based certificate authentication improves security. Policies define security associations for encryption algorithms and keys. Integrated with modern WAN and SASE frameworks is required for enterprise VPNs. Now, we will discuss another leak, another problem that was happened in 2020 regarding this one is known as Fortinet VPN credential leak. Attacker exploited unpatched FortiGate devices because there was a vulnerability, and so attacker exploited it and compromised IPsec credential and configuration files. Mitigation was regular patching is required. Certificate-based VPN authentication is also required in most of the cases. So this particular Fortinet case studies were very popular when dealing with the VPNs. If you want to deploy your work with the VPN, then I think you should understand the Fortinet issues, because compromised IPsec credential and configuration files, that will be a great loss for a particular industry, FortiGate devices. Now, HTTP, as you have heard, so HTTP, it means the HTTP plus TLS. I think it is clear to you. I assume that you are aware about the basics of the cryptography. So HTTP and TLS both are using in HTTPS. So it ensures the secure transmission between browsers and servers. And HTTPS use CA issued, certificate authority issued X.509 certificate for trust, and essential for our e-commerce, e-governance and digital payment platforms. Without this, all these cannot be possible. Like you want to use banking transaction, then you need to use the HTTPS first. After that, you can go with the transaction. Now, another is the secure email communication, secure multi-purpose internet mail extensions. All these are using the secure version of the X.509 certificate for sender verification and adopted in corporate and government communication. Nowadays, multiple organizations in government sector, multiple PSUs, even though universities are using this secure multi-purpose internet mail extensions. because it provides encryption and digital signatures for emails. And it's a good initiative, and it's good innovation as well, because it provides digital signatures for emails. Secure protocol interoperability. As the name suggested, secure protocol. So enterprises deploy multiple secure protocols simultaneously. Integration challenges are there. Multiple challenges are available for management purpose, like life cycle management, key storage management, trust alignment management. Yes, all these challenges are available, but the solutions are still available in up to a certain level, like certificate automation platforms, centralized PKI management. All these solutions are available, but very few are the challenges itself. You can start work on this part, and you can go with the research in particular domain, like this integration challenges in secure protocol operability. As I share this PKI, so global PKI adoption trends, I want to share with you. Almost 92% of the organization globally, not even in India, globally deploy PKI for digital identity and encryption. And with this particular PKI, public key infrastructure adoption, the rapid growth driven by zero trust architecture adoption, cloud and IoT integration, digital payments expansion. So all this is possible just because with the help of PKI infrastructure deployment. Average enterprise manages over 50,000 digital certificates. Automation tools, these are very few, like Benafi, DigiCert1, AWS, ACM, and all these are very few automation tools. We have a list of automation tools, and you can use any one as per their requirement. If we talk about Indian perspective, right? Because we are in India right now. So what is the trend of PKI in India? So PKI Indian landscape is required to discuss. As a professor in this domain, I'm working in the cyber security right now, and I am contributed in ASTIC 2025 through a presenter there. So I can say a few words like this. A PKI landscape is very, very required in Indian perspective. PKI landscape in Indian perspective governed by the IT Act 2000, and controller of certifying authority is the responsible authority for this PKI. In India, like eMudra, NSDL, e-governance, Capricorn CA, all these are the certificate authorities, and anyone can take the license from eMudra, N-Code Solutions, NSDL, e-governance, and you can get the license from there. Very well-known use cases are Aadhaar-based e-sign, digital locker authentication, GST income tax e-filing, e-procurement, e-governance portals, all are using PKI in India. If you have developed any kind of browser with security, then you need to implement the CCA root CA certification of India. So CCA root certification is required. Indian web browser is also having this certificate, CCA root certification. And I have used this root certification in Indian web browser, so that I can say particularly that India's National Root Certificate Authority, that one is CCA Root Certificate Authority. You need to know more about a CCA Root Certificate Authority, then you go and check India's National Root Certificate Authority, and it's very good certificate authority. Now, next case study is regarding the India's digital signature ecosystems. You need to check where we stand and what we are lagging, and how can we improve our status from one point to another point. Nowadays, over 80 million digital signatures issued by licensed certificate authorities like e-Mudra, ANSDL, e-governance, right? Like this. So licensed certificate authority have issued, as on date, 80 million digital certificates, and the number is increasing day by day. Digital signature ecosystem is widely adopted in corporate filings, tender submissions, and judicial systems. In this particular digital system ecosystem, X.509 version 3 certificate is there, RSA 2048 is there, OCSP for live revocation checking is there. And in this particular ecosystem, that enable legal non-repudiation and trust in online contracts. This is very useful in case of sender non-repudiation is required. You all are aware of the Digital India mission, right? So I want to tell you one thing, that the PKI in Digital India, this is another use case. PKI ensures citizen authentication in digital locker, e-hospital, Umang apps, e-sign APIs allow paperless signatures using Aadhaar-based PKI credentials. Trust model, like in our Digital India mission, we are using Root Certificate Authority, e-sign service provider, and user certificate. So reduce the cost, ensure privacy, and support scalable identity management is PKI we are using in Digital India. All of you are heard about this mission. If you know more about Digital India mission, then there is a organization available in MATI. That one is called as India AI in Ministry of Electronics and IT. You can get the more information from there, PKI in Digital India mission, and it's very good in initiative by Government of India as well as Ministry of Electronics and IT. And I am referring this particular work from their India AI mission. Now, next one use case is smart cities and IoT security in India. We are using smart lighting, surveillance devices, traffic management, and all these require a strong device identity. So PKI public key infrastructure ensures mutual authentication between sensor and command center. I want to give you one example like Pune and Ahmedabad smart city deployments using device certificates. Right? If you are in Pune or Ahmedabad, you can check this deployment. A smart city deployment where device certificates are available. Integration with IoT gateways using lightweight enrollment over secure transport protocols. So this is the smart cities and IoT security trends in India, that we are using all kind of devices be the device identity deployed at multiple cities, and day by day this deployment will be increases in near future. Another huge case of PKI in financial sector and RBI guidelines. RBI has mandates PKI based encryption for digital payment system. If you want to perform some transaction through any bank, then you need to use PKI based encryption. So PKI ensures, like, if you want to perform NEFT, RTGS or UPI, so all these ecosystems use PKI. Bank deploy hardware security modules for key storage. And digital certificates used in API signing for UPI transactions and Aadhaar KYC interfaces. All these are the best use case of PKI in Government of India applications. Right? If you want to work on this deployment level of PKI into your work, then you need to check the working of this PKI in digital payment system, then you can start your work also. This is one research direction. Then how can you start PKI work with your infrastructure? It will be a great push in security sense if you use PKI in your network. Now, in this session, we will discuss the global threats and those threats which are targeting PKI. So, particular session, this is regarding PKI. So, these threats may be in other dimensions, but I want to tell you that what's global threats targeting PKI. Certificate misissuance, like insider compromise or rogue certificate authority. So this is one main problem, the certificate misissue. Expired certificate is another issue. That Microsoft Teams 2020 is having the expired certificate. Then massive outage will be there. Supply chain attacks, tampering with signed software like SolarWinds 2020. So all these tampering can be done. Supply chain attacks may be there. Key exfiltration, cloud misconfiguration expose private keys. If in your system or in your cloud, there is misconfiguration, then it may expose the private key. Then it will be a great problem for all of us that will create a global threat in PKI. There is a case study in 2020 that one attack is called as SolarWinds attack. Here, affected is US government and Fortune 500 companies, where malicious code signed with valid certificate, malicious code, to evade detection. Right? So what is the lesson with this SolarWinds attack? After this attack, we learned that the PKI alone cannot ensure trust. Okay. So PKI alone cannot ensure trust without integrity in the signing workflow. This is the main lesson from this SolarWinds attack. Without integrity in signing workflow, PKI alone cannot ensure trust. So you need a particular PKI with set of rules that ensure trust. Another case study is from the Microsoft Exchange server that was happened in 2021. Here, in this particular Microsoft Exchange server, exploited invalid SSL certificate chains for C2 communication. Attacker installed Wave cells under legitimate certificate entities, and it revealed need for continuous certificate transparency and monitoring. Indian cyber threat statistics. As on the data I have received for up to the last year 2024 data, and because we are in 2025, So the next data will be available in I think January or in December regarding the threat statistics by these national survey organization. So 1.3 million cyber incidents reported by certain in up to 2024. In particular, 2 or 3 years, phishing and data theft attacks rose 45%. Right. So we need to focus on this part also. Another statistics is related to the 38% of the financial breaches. Because I am the cyber security person here in slide and chief information security of our organization, CISO. So I can tell you one thing, that phishing and data theft attacks are exponentially increases in last 2 or 3 years. That's why I can write like this, that this attacks rose 45%. 38% of the financial breaches traced to expired or misconfigured certificates. And this is the one important point here is, attackers what gets the vulnerability. Generally, in general sense, attackers can see the expired or misconfiguration in your system. If you are using cloud and cloud misconfiguration certificates are available or misconfiguration in that sense, then attacker can use their advantage that one is expired or misconfigured certificate. So 38% almost, as per the statistics of financial breaches, traced to expired or misconfigured certificate. So where we reach, where we give our feedback, where we get response from the government side. So National Cyber Coordination Center, NCCC, NC3 agency is there. And this National Cyber Coordination Center strengthen PKI-based digital trust. If you have any questions regarding the National Cyber Coordination Center, then you can directly reach with this website, National Cyber Coordination Center, Indian National Cyber Coordination Center. Website is available. You can write in context us section, and then you will get reply from that part. If you want to give your suggestion, then the suggestion will be very helpful for National Cyber Coordination Center. Another case study of 2023 that was regarding the Digi certificate revocation. Major cloud services impacted due to this revocation in 2023. Revoked all around 1 lakh certificate due to compliance issues and issuance. Emphasized automation and health monitoring of certificate life cycle. So this was happened in 2023. Revocation was impacted major cloud services. If we talk about PKI in cloud native security, cloud PKI services like AWS, Azure, GCP, automate certificate provisioning. This is all done with the help of cloud plus PKI. Kubernetes clusters uses PKI for node authentication, service to service TLS connections. And when you are on the cloud working environment, then you need to work with these secure communication channels, that your work should be so secure from one end to another end. So service to service TLS connection should be there. And Kubernetes clusters use PKI, and you can use this cluster as a secure medium. And DevSecOps pipelines integrate PKI for code signing and CD integrity. it is good for cloud native security. And we can, if you want to work on this particular cloud native security, the research areas are open, like load balancing, certificate provisioning, management, certificate authority management, and particular key management. So all these areas are open for research nowadays. If you want to start work, then you can use AWS, Azure as a deployment medium, and you can get the results from the AWS and Azure, or you can submit the research here in particular journal like IEEE transactions specifically. So PKI in cloud native security is in a transition mode right now. You can start your work here with AWS and Azure and give your proposals. As I told you, we are in the transition time of PKI in cloud that is similar with these 5G and telecom infrastructure. 5G and 5G Advanced. 5G network requires strong mutual authentication between network slices. PKI used for SIM-less like eSIM provisioning, G-Node B identity, and core network encryption. Department of Telecom and TRAI emphasize PKI control and 5G security guidelines. So PKI in 5G and telecom infrastructure we are using right now at some sense, like Apple user, iPhone user are using eSIM, and other operators are also providing the eSIM. So PKI used this SIM-less eSIM provisioning, and node identity will be done with the help of PKI. Mutual authentication is required for particular network slices. So it's a very good security guideline, and that one is released by DOT and TRAI, and which is available freely to anyone. If you want to read, you can check the DOT website for 5G security guidelines regarding PKI. This is another segment or another application area where we are using PKI in healthcare and IOMT. PKI, I have told you the PKI ensures device authentication, secure telemetry, data transmission, and non-repudiation. So medical IoT devices are using PKI in healthcare. So medical IoT devices exchange sensitive patient data. So India's National Digital Health Mission uses PKI for health identity authentication. This is Health Mission, India's National Digital Health Mission. You can get the information about the status of this mission from the Ministry of Health, and Ministry of Electronics IT is providing the PKI support for health ID authentication. PKI in healthcare is at a medium level, and we can contribute regarding insecurity if you want to develop more from the existing one. Another application area of PKI in supply chain. So this is the used for code signing, firmware integrity, and secure boot chains. Global vendors like Intel and Cisco use digital certificates for hardware validation. PKI-based hardware root for trust under Make in India. This is another, and this is very essential because supply chain security is at most required. Multiple organizations have used PKI in supply chain security. So as an Indian person, as an Indian manufacturer, or as an Indian enterprise person, we need to deploy our PKI in supply chain security. Now, this segment is related with the governance. So PKI for e-governance. Example is NIC is using PKI in e-Praman Federal Identity Framework. E-Praman. So PKI links various ministries and state departments via cross-certified certificate authority, and it ensures applicable secure API label data exchange in e-district and BharatNet project. And government is working very fine with this PKI with the government services. Operational challenges are multiple challenges are operational in PKI management, like manual certificate renewal causing outage. You can see the example of Slack in 2023. The lack of visibility across multi-cloud environments, insider misuse of issuing authority roles, and need for centralized governance, risk compliance, and GRC dashboards. So all this, these are the four, only four, not only four. I have listed only four here. You can see multiple operational challenges in PKI management when you will deploy. So manual certificate renewal, this is one of the main challenge I have seen. If you have any solution regarding this, that will be a great benefit for me as well as for the industry as well. And one of the important point here is insider misuse of issuing authority roles. We are in government sector. We have seen and we have read the multiple cases of insider misuse of the issuing authority roles. So how can we prevent this? This is operational challenge. Lack of visibility across multi-cloud environment. When we have multiple clouds in a particular service, then we need to work on the visibility part. Need for centralized governance, risk compliance dashboard. Because if you have any problem with this system, if you have any risk with this available system, then you need to work with the centralized portal. So there is a particular need for centralized governance, risk compliances dashboards, where we can find out what are the available grievances or risks available. In India and global, if we talk about the regulatory perspective, policy perspectives. So in India, specifically, all you are aware about the IT Act 2000. This is available all over, publicly available document. You can read. Another guideline which is available in certain guidelines 2022, and another revised guideline is available in 2025, certain guidelines. METI Cyber Assurance Framework, Ministry of Electronics and IT Cyber Assurance Framework is available. So I have listed three. You can see multiple other initiatives are going on in India with this information technology sector, like India AI Mission. In near future, like in February 2026, Global AI Conclave will be going to organize by Department of Science and Technology, and that Global AI Summit will comprise the almost all AI verticals, and that one is organized by the government of India. So multiple initiatives are going on in the field of IT. If we talk about global perspective, so EU, European Union, and United States are at top, because NIST, NIST, and NIST itself is from US. So US and European Union are playing very good role. ISO number is available 27,001 2022. So globally, it is tackled with mostly US and EU. Multiple other initiatives are also available in country to country. You can find out by checking the country PKI labels. In general sense, we can say like this: the PKI auditing and transparency logs are important. As a CISO from slide, I can say organization need to use and implement the best possible guidelines offered by government as well as global organizations or ISO standardizations. We need to install and implement in a very true sense. So auditing and transparency logs under CAB forum baselines, and this should be mandatory for all of us. If we talk about the future of this particular PKI and the future of this particular secure protocols, in quantum computing specifically or quantum communication, there is a much exponential growth going on in quantum, post quantum cryptography, post quantum PKI, and quantum safe protocols. NIST standard Kyber and dilithium that was available from since 2024 for quantum resistance key exchange and signatures. As I told you, we are in the transition phase. So RSA maybe will not be a great choice for all of us in near future. So hybrid certificate will be a great choice, like RSA plus PQC. You can use dual stack like TLS 1.3 plus PQC integration. India have also launched a national quantum mission with 6,000 crore rupees to encourage research on post-quantum PKI algorithms, post-quantum cryptography. National Quantum Mission NQM is there, and in ASTIC 2025 there is a particular stall that one related to the QNU and QPI AI startups were there, and all these startups are important key player in National Quantum Mission. I have visited their stalls in ASTIC 2025, and I discussed the progress of the quantum algorithms. They said the particular person which were available at the time of the showcasing or demonstrating their quantum computers, and in near 1 to 3 years, we will see a great advancement in quantum computing from India side. So NIST is also developing the quantum resistance key exchange and signatures. But as an Indian person, Indian researcher, and NQM is also working on the same sideline. If you have any research proposal or any idea regarding the post quantum cryptography, then you can directly access the NQM and they will fund immediately for your idea if your idea is so good. Now, as a university professor, right, our main questions like this: how can Indian university adopt institutional PKI for secure academic records? We are in India, in universities, mostly all are using manual files. So can we use the institutional PKI for secure academic records? If yes, then go ahead and use institutional PKI for secure academic records. And that will be a great key takeaway from this FDP. Search on internet and check, is it possible to deploy in your institution the institutional PKI? Next question is regarding what standards should industry follow for PKI automation and compliances? So if you want to deploy the PKI standard as industry, so you need to focus on the automation part also. If once you deploy, then you first check the regulatory or routine or periodical review. If there is some problem, then compliances should be there, and regular compliances should be there. In upcoming time, you can see that the help of AI or ML, you can easily detect anomaly detection. So yes, AI ML can assist in certificate anomaly detection and revocation protection. Yes, answer is yes. But nowadays, it is in initial phase. In 5 to 10 years, it will be settled down, or it will give the best result for all of us. As a faculty from this particular research area, so if you want to key takeaways from this particular session, so I want to ensure 4 things. The first thing is regarding that PKI is the core of digital trust, right? If you want to deploy in university, then it will secure your cyber ecosystem, university cyber ecosystem. If you want to use or deploy in industry, then it will be a great benefit for industry as well. And if you want to submit some research project in your agency, any external funded agency, then you can plan a research proposal in somewhat sense, like we will use PKI for this application like finance, healthcare, IoT, and defense, because these are the thrust areas where the PKI can be applied in real sense. Real world attacks shows that the importance of governance and automation auditing. Right? So you can start work on this particular type real world attacks and mitigation approach. I'm also working on this side. So my future focus is quantum safe transition and AI driven PKI governance. You can also start the work regarding with the quantum safe transition, how to mitigate the quantum based attacks. So RSA plus PQC both are combined, then we can go ahead with this quantum safe transition. Right? So near future, we will see there is a transition from normal cryptography to the quantum based cryptography. Okay, so now it's time is 8:50. I think this is the last slide. I'm thankful to the organization of the FDP Cybersecurity Bootcamp, Safeguarding System and Networks. Now, platform is open to all. If you want to share your insights as well as you want to ask your queries, so you can ask, unmute yourself, and share your keywords with us. Any one of you, please share. your insights regarding the importance of the public key infrastructure and secure protocols nowadays in real world, because we are living in a heterogeneous and digital environment. In smart homes specifically, we have list of sensors, list of devices in heterogeneous sense. So there is a particular need that we should be secure enough while transmission is going on. So if you have any query regarding this, I'm happy to share. I have to happy to deliver this kind of sessions.
Thank you, Dr. Jagdeep sir, for a very informative and which includes so many case studies, which really opened our eye towards the scope of cybersecurity and the necessity to study it and pursue research. And you given us freely so many research options where we have to start. That way, it was very beneficial. And I would like to know one thing about device IDs. That in IoT we have to need device certificates. How that will be implemented? All the devices will be communication enabled or need IC enabled to make them communicable. That simple devices making them that much smarter. How that cost effectiveness will be affected. These are some simple thoughts from my side, and kindly give me some insights, sir.
Very good query, and very good questions. I mean to say, that's a perfect questions regarding this the main challenge we are facing right now, because we have the MAC address of each device, right? The physical address, and if you want to use that one in the identification, so there is a Mac spoofing as well. Nowadays, we are facing such kind of issues. I want to tell you the real sense. Mac is available, and with the help of Mac, we are using to authenticate the device. So device ID is directly linked with the particular vendor number, particular batch size, and the particular device model. But there is a problem right now. We are facing that Mac spoofing. Um, so PKI will ensure that up to a certain level there will be no spoofing at all. But with the help of recent and correct configuration of the available settings, we can figure out the solutions. In a lab setup, I have done this, but in a large project, there may be some kind of another problems. So I can say, based on the availability of the devices or heterogeneousness labels, we can figure out the solutions. There may be a hit and trial methods also.
Thank you, sir. Now I am expecting some feedback from the participants. They can also have so many questions or
Yes,
findings.
one hand is raised by I think Javed Khan. Javed Khan, do you want to say something, Mr. Javed? Oh, okay, no problem. Uh, so, ma'am,
I am
it was
expecting some
very
feedback from
nice.
the participant side also.
Yeah.
Kindly, some of you give some insight and how to improve or what we have to think more.
Yeah,
We
because India
made so
AI
many.
mission is going on. So if you want to contribute and you want to showcase yourself in national level, then go and check the India AI mission. It's a very good initiative by Government of India. And last first week of this November, 3 to 5, I was there in Bharat Mandapam, Pragati Maidan, in Emerging Science and Technology Innovation Conclave. In that conclave, I have seen multiple innovations in this particular cybersecurity domain. So, all of you, please, I recommend you, please visit the website of Ministry of Electronics and IT for AI and cybersecurity innovations. It's very good platform to check what is going on in the city, what is going on in your nation level, what is going on in your state level. Please go and check.
Thank you, sir. At the academic level, we have less exposure to IT security, and still in small colleges like ours, there is no role of security officer appointed, and everything is managed by computer staff, and
Oh my God.
not training is giving. And I think from our organization side, the need for such a post and their responsibilities are not clearly defined and executed till now. That I will try to convince authorities to set up such a environment before going further. Thank you all
And
the participants.
there is a post that one is called a Chief Information Security Officer,
And that,
CISO.
yes.
So you can ask with your designated competent authority, and he will give you some permissions regarding this. And you can act as a CISO. There is no problem in that.
Actually, CISO position is not defined in our institution.
Oh,
All are managing with the support of others only. And websites we are doing with third party in digital certificate, etc. In using our office, that also need to be managed. That by computer programmer like that, and
computer
they
program.
are overloaded also.
Mm-hmm.
That I think we have to make some step forward towards the CISO role.
So
Thank you,
go.
sir.
Okay, okay. Go ahead, ma'am. Go ahead.
Thank you. Any other comments from the participant side? Please come
I think they
forward.
are writing.
Our time going to end now.
Sir, good
Yes.
evening.
Good evening.
I would like to extend my most sincere gratitude for serving as a resource person and delivering an exceptionally insightful session on public key infrastructure and secure protocols. Your presentation was nothing short of a masterclass in making a complex subject both accessible and fascinating. We were impressed by the way you structured the session, taking us on a journey from the history and fundamentals of
Some
AI
interruptions.
practical workings, including digital certificates, trust models, and real world case studies. The inclusion of Indian cyber threat statistics and the Indian PK landscape grounded the discussion in real world relevance. The insights so generously. It was a great learning experience, and we eagerly hope to have the opportunity to learn from you again in the future. Thank you, sir.
Sorry for the interruption. In our hilly area, some problem with the network and signal problems are common because in the some side of the hill, signals are not available. It is late night, so most of them are in the quarters like that.
Okay, okay.
That's a problem. And okay, thank you, sir. Thank you for accepting our invitation and serving us.
Yes.
Thank you all. Thank you all the participants. Now it's our time to end. I think all of you got the feedback form. And
Thank you, sir. It's very informative, sir.
Thank you so much. Thank you, everyone. You can contact me on my email, jagdeep@slide.ac.in. This email is available. You can write.
kindly post it in the
Sir, can you share it in the
message,
group,
sir.
sir?
Yeah,
Kindly
yeah.
type
Message.
Sir,
it
can
in.
you post it in the message in the WhatsApp group?
Uh, okay, in WhatsApp group.
Sir,
Yes, sir.
Okay, I will share there as well.
here
And
in
I
the
write.
message you post, sir.
Right. You can contact me anytime, anyway, for any work of the cyber security or network security work. I'm available for help. Thank you so much for
Thank
invitation.
you, sir. Thank you.
Thank you.
You can
Nice
kindly
meeting-
leave now, sir.
Nice meeting you. And I would like to invite you in person in Punjab.
Okay, will you allow us to see your premises and have more knowledge about cybersecurity? We will arrange some industrial training or visit or academic visit like that. Our students are coming that side also.
Okay.
Okay,
Thank you
thank
so
you.
much.
We can meet again, sir. Thank
Bye
you.
bye.
Good night.
Good night. Good night.
I hope all the participants receive the feedback form. We will stay some more time and I will share all the PPTs available with me. And I will post the YouTube video at the earliest. Thank you. Thank you for the patient listening. Any shortcomings,
Thank you.
kindly send me the messages.
Thank you, ma'am. Thank you, ma'am. Very informative, ma'am, today.
Okay. Any breaking, anything happened in meeting?
No,
Communication?
ma'am. No, ma'am. No.
Okay.
We
Thank you.
feel very nice, ma'am. Very informative. Thank you, ma'am.
Thank you, sir. Thank you, all the participants.
So stop here. Sujit sir,
ഓക്കെ ടീച്ചറെ
നമുക്ക് റെക്കോർഡിംഗ് സ്റ്റോപ്പ് ചെയ്തിട്ട് ലീവ് ചെയ്യാം.
ഓക്കെ ഓക്കെ
Thank you, Jagdeep sir. You can leave now. Stop here, Lambu.
സ്റ്റോപ്പ് ചെയ്യാം.
On clarification, Mandalo. I contacted for the tomorrow faculty also. I will reach there in the morning. Good night.
Okay.
Good night, all.